cofunction identities. So what we're going to do here is basically just work with sine and cosine, and then you're going to find the other four cofunction identities. There's really a couple ways you can do this. So what I'm going to do first is just think about this triangle in terms of sine and cosine. So if I work with a right triangle, right, if I let this be theta, and this is obviously a 90-degree angle, that would make this angle 90 degrees minus theta, because all three angles have to add up to 180. So if you have theta plus 90 plus 90 minus theta, there's only 90 degrees between these two to share. So if this one's theta, this one has to be 90 minus theta. So what I want to do is, if I look at the sine of theta, right, so we're going to write down now, right, if I have sine of theta, in this example here, we don't have to worry about x's and y's, that's y over r, but in this case, sine of this angle is opposite, which is b, over the hypotenuse, which is c, right? That is sine of theta. Now, if I look at this angle here, which is 90 minus theta, let's just pretend that's like its own label, just like theta is, right? If I look at the cosine of that angle, cosine of 90 minus theta, the cosine of this one is its adjacent, which is b, over the hypotenuse, which is c. So what you guys can see is they're actually the exact same thing. And that's basically what a cofunction identity is. If you have sine of theta, it would be the exact same thing as cosine of 90 minus theta, basically the other angle in that triangle. So that's kind of one way to show it with the triangle. If you think about it in terms of your unit circle, you could certainly do it that way. Like if we had sine of 30 degrees, right? We know that sine of 30 degrees is 1/2, right? So if I think about 90 minus 30 degrees, right? So this is 30 degrees. If I think about 90 minus 30 degrees, that's 60, right? Oops. Let me undo that. 90 minus 30 degrees would be 60, right? And if I think about cosine of 60, which is 90 minus 30, that is also 1/2. It's just the x-coordinate right there. So it's just showing you that the two are actually related. Sine and cosine are cofunction identities. So that's kind of the first one that you have. You have sine of theta is the same thing as cosine of 90 minus theta. And then you have cosine of theta is the same thing as 90 minus, or same thing as sine of 90 minus theta. Which is why when we graphed them, that they're basically only pi over 2 shift, a horizontal translation of pi over 2, and then it would spit the other one on top of itself. So what I want you guys to do now is just find, using this, right? I don't want you to rewrite sine of theta as reciprocals or anything like that. Try and find the cofunction identities for tangent, cotangent, secant, and cosecant, kind of written in this exact same way.